For sending instructions or evading predators, chemical communication can be key. But such subtle messages can get lost in the shifting currents of the big blue sea. For long-range communication, some animals evolved a more powerful way of getting their message across. Sound. Each year in Cape Coral, Florida, residents encounter an unexplained phenomena. A deep series of sounds rattle the walls of their canal-side homes.
It would be like dum, 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 all through the house.
For years, the source remained a mystery, until word reached David Mann, an oceanographer at the University of South Florida.
We heard through the grapevine that people were hearing these strange sounds at night in their houses. One of my grad students, Jim Locascio, actually went down to the city council meeting and said, I know what it is, I can tell you what it is.
One night, Locascio took his research boat down to Cape Coral to confirm his hunch. He brought with him one instrument, a waterproof microphone, the perfect tool to pinpoint the surprising source.
Come out on the water and it's a peaceful night, it's quiet. We really don't hear anything except the gentle rocking of the waves. But if we put a hydrophone under the surface of the water and we use a simple handheld speaker, we experience an entirely different landscape.
The culprit, Locascio discovered, was a fish. One with an apt name, the black drum. Locascio had long known male drumfish to be some of the loudest creatures in the sea. He also knew they didn't make that noise for the sake of it. They were communicating with one another.
These are all males advertising themselves to females that will ultimately choose who they mate with.
For a male drum, being loud increases their chance of passing on their genes.
The males are making this sound going ba-boom, ba-boom, ba-boom to attract females, and they like to do that between 7 and 2 a.m., just when people are trying to go to bed. So the sounds are so loud, they travel right through the seawall, up into the house. It's amazing. You can go out into the driveway of these houses, put your head down, and hear the sound of the fish coming from 100 yards away.
But why is sound such a powerful channel of communication in the ocean? Here, light is in short supply. Chemicals quickly dissipate, but for sound, water acts as the ultimate conductor. Sonic signals pass between the dense molecules of water like an electric current, traveling farther and 5 times faster than on land.
Sound for animals that live underwater travels great distances and weakens very little over those distances. And so it's no surprise to learn that many marine animals rely on sound as a communication channel.
Scientists have long known fish to make all manner of noise, from clicks to chirps to croaks. It's likely that their common ancestors, the first fish who evolved 500 million years ago, couldn't produce such sounds. But then fish evolved organs that would allow some of them to be master communicators.
As fish evolved, they evolved a swim bladder, which is an air bladder that's inside their stomach that they use to maintain buoyancy.
Fish initially used this adaptation solely for hovering in the water column. But over time, it evolved into the instrument that would give drumfish their name.
They've evolved these special muscles that twitch extremely rapidly. They're the fastest known twitching muscles in the vertebrate world. And they basically contract their muscles together and beat the swim bladder like a drum.
This adaptation would help the male drumfish attract mates. But while the volume of many fish calls is considerable, they can't rival those of another order of marine life that emerged 50 million years ago. The most powerful communicators in the sea, whales. Not only are whales the Earth's largest animals, They're also the loudest. Their ghostly songs resonate throughout the oceans and can exceed the decibel level of a supersonic jet engine. How and why have whales developed such an ear-splitting method of communication? What do whales communicate to each other? And how has it played a role in these enormous animals' survival?
It's the beginning of the 21st century, and we've only really just been listening to the ocean on a proper scale for less than a decade. So we're in the early stages of discovering what is actually going on with the communication system of whales.
Wide-ranging and few in number, whales have been elusive research subjects. But Chris Clark, a bioacoustics expert at Cornell, wondered if he might be able to decipher the messages in whale communication.
From here up is already connected.
But in order to do that, he had to figure out a way to track them. Collaborating with other marine research groups, he devised a way to eavesdrop on whale conversation.
We've designed and developed these auto detection buoys so we can get information back rapidly over the satellite system. We also distribute a network of bottom units, these pop-ups, that collect data continuously.
The pop-ups are positioned to capture every whale call within a 300-mile radius off the New England coast.
You ready? 1, 2, 3.
Once the pop-ups are retrieved, the recordings are sent to Clark's lab at Cornell. He and his team are then able to use whales' calls to precisely map their movements.
We acoustically locate the animal using the known positions and the speed of sound and measuring the time differences. We can actually position the animal in the bay.
For years, scientists believed whales were loners, rarely interacting with other members of their species. But the acoustic maps pointed Clark towards a surprising discovery.
So here are two whales that are counter-calling back and forth, and they're going to join up. They join up, move, then split up. One goes to the east, one goes down here, joins up with another whale. This one goes up here, joins with another whale. So there's this constant chatter back and forth of everybody's checking in and calling and then joining up.
Clark's data reveals that these whales are actually social animals that travel in loose-knit groups to share food and find available mates. But unlike other social creatures that live and travel in close proximity, whales traverse huge swaths of open water.
If you look at these animals from a satellite and you watch them over time, you see them moving as a cohesive body of individuals. It's an acoustic herd, and the herd is spread over 100,000 square miles.
To communicate over these large distances, whales develop powerful low-frequency calls. With the right conditions, the bass notes of some whales can traverse entire oceans.
I can hear a whale that's singing off of the coast of Canada when I'm in Puerto Rico. The voice is so low and radiates through the ocean so efficiently that it travels almost as though it's a laser. It just travels very, very efficiently in the ocean.
For millions of years, these giant animals have used this channel of communication to ensure their survival. But as it turns out, another group of titans is now operating on this same frequency: ships.
Most of the time, you just hear this fog, this noise. It's indescribable. It's just sort of there. And it's been increasing, doubling in size every 10 years.
Human hunting has driven many whale species to the brink of extinction. Clark now wonders whether human noise will eventually push them over the edge.
If I only have a chance to communicate with you 1 out of 10 times, how do I tell you where the food is? How do I tell you whether I'm a high-quality male? I evolved to communicate over this scale, and now I'm forced not because of anything else other than noise, to live in that world.
Our continued disruption of whale communication appears inevitable. Only time will tell whether the world's largest animals can evolve to overcome this challenge. Whales would use sound to conquer the ocean, but on land, animals would need special equipment to ensure their survival.